Okay, June 15, question 4, no, 4, 3, which is Paolo selling vegetables, and he is after selling from the van. He wants to drive around the street, so he's driving around every single street, and that's his problem. He wants to drive around every single street, it's question 4, and get back as quickly as possible. So this is a Chinese postman problem. So you need to make the graph Eulerian to be able to do this. They've given us the total time. So the first thing I want to do is to indicate what all the nodes are, would be one thing to do. What degree or order the nodes are. So this is degree 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay, given it is a Chinese postman, there should be a maximum of 4 odd nodes. So if we write here now, oh, not really writing, odd nodes, A, C, this one, E, and G. Okay, so because we've got 4 odd nodes, we need to pair them up. So we're going to do A and C, A and E, and A and G. And if we pair up A and C, then we've obviously got to pair up E and G, otherwise they'll still say odd, and if we don't include a link between them, and therefore it'll be semi-Eulerian, and we're after it, the graph to be fully Eulerian for us to work this. So if I do A and E, I'm left with having to make a connection between C and G, and if I do A and G, I've got to do something between C and E. This layout is the way they want it, so you are expected to write it in this format to get full marks. Okay, so A to C, here's A, we want to go to C, so looks like the quickest way is just going to be 6. E, wherever E is, to G, looking at this, it's going to be 9.5. Okay, so altogether that's 15.5. A to E, well, all the way across the middle, so there could be various routes available to you. So don't want to do that one. So that one looks like this one, 3.5 plus 8 by the looks of things. No. So 3.5 plus 8 would be 11.5. 3, 7, 8, 9, 10, 11. Right, so this is the route which gives you 11. So A to E is 11. That's a bit out of the way. And then C to G. C, there's G to G. Oh dear. What have we got? 0.5, that'd be 4. 4. 12.5, I think that's it, isn't it? So 12.5 there. Normally I'd probably write down what those routes are in case we've got to draw them in later, and I'd write them up here, so you're going A to D, oops, to D, to I, to H, and then to G, just to give myself an idea in case I forget, because it is an exam after all. So that gives us a total of 23.5, and the last one, A to G, looks like the quickest is 7, and C to E, the shortest is going to be 8, which gives us 15. So this one is our smallest one. So the minimum time would be the 79.5 that we've got from there, plus our smallest one, which gives us 94.5 minutes, because we're talking minutes here. Second part of the question, over here. Oh, no, there it is. Let's have a look. So B, for an optimal, so find the length of the Chinese postman from A. Shortest routes between the verses may be found with inspection, so it's giving you a hint there's probably a nasty one. For an optimal Chinese postman route, find the number of times the vertex F would occur and the vertex D would occur. So from this one that was our optimal, AG was going from, let's get the pen, different colour now. Okay, we're going from A to G, which goes in here and then in here, and then C to E. C to E was going from here to here. So now this node has gone 1, 2. So we're interested in, I can't remember which one, F and D. So for F, where is F? A, B, C, D, E. F is here. Nothing much has changed, so that would still be two times. Because it's got a node of 4, so you go in and out, okay? And then D, which is up here, 1, 2, 3, 4, you would end up going in and out 3 times to get 6 nodes, or 6 to get it of order 6. Okay. Next question. So Toto is standing for the position of mayor in the local election. He intends to travel along all the roads at least once. He can start his journey at any vertex and finish his journey at any vertex. Find the length of the optimum route for Toto. State the vertices from which Toto would start to achieve this. Right, so that means, like I said up here, you could just make one connection and leave the other 2 as odd. By leaving them as odd, you've got a semi-Eulerian, which means you could start and finish at either of these if you didn't add this one in. So you have to look, using the table now, nothing else, you look at all these numbers in here and see which one is the smallest. Because 6 is the smallest, you want to repeat that one. So repeating that means you're repeating A and C. So if you're repeating A and C, then you're just going to do 79.5 plus 6, which gives you 85.5 as a time in minutes. But if you're repeating this one, A to C, you're not repeating this, which means these 2 are the odd nodes, which means you could start or finish at E or G.